So after observing the free electron theory and its failure in explaining certain phenomena and certain observations, the Sommerfeld model was observed to be much successful model compared to the free electron theory. So this Sommerfeld model basically takes into account of quantum statistics and Pauli's exclusion principle. These are the major. So these are the major points considered by Sommerfeld. Okay. One is quantum statistics was considered by Sommerfeld, and the Pauli's exclusion principle that was considered by Sommerfeld. Okay. So what is the major difference between this free electron theory and Sommerfeld model is that it makes use of quantum statistics, that is Fermi-Dirac statistics, and it considers the Pauli's exclusion principle. Okay, adanna consider ಮಾಡ್ತದೆ. Okay, so that is how it is different from the free electron theory. So what are the major assumptions of Sommerfeld model? We'll see. Number one, according to Sommerfeld model, the free electrons are the valence electrons of the composing atoms. Okay, so whatever the free electrons present in the metal are the valence electrons. They are available for conduction. According to this statement, only valence electrons are contributing for the conduction of electricity and heat, not all the electrons. That is one point. Second point, the valence electron in the metal finds itself in the fields of all ions and that of all other electrons. So every electron experiences an electric field due to all ions and other electrons. So there is a interaction between them. In this model, the mutual repulsion between the electrons is neglected. The mutual repulsion between the electrons is neglected, and the potential field representing the attractive interaction of ions is assumed to be completely uniform everywhere inside the solid. So it says that the potential field due to ions is uniform and electron repulsion is almost neglected. So the interaction between the electron is negligible and interaction between the electron and the ions is thoroughly uniform. That is very important point. Okay, so uniform potential field is assumed. Uniform potential is assumed. So there is no work needed to move the electron from one point to the another point. So that is the point noted here. The potential field is uniform, means there is no potential difference. Okay, so external potential difference is required in order to create the potential difference. So internally, there is no potential difference between the electron and the ion electric field. That is one point. Third point, the potential energy of an electron at rest inside the metal is assumed to be lower than that of electron inside the metal, outside the metal. So inside the metal, the potential energy of the electron is negligible, and outside the metal, it is a little bit larger. And potential energy for an electron is periodic. That is in accordance with the quantum mechanical model called Kronig-Penney model. So Kronig-Penney model, that model says that the potential energy of for an electron is periodic, and it is based on Bloch theorem. So if you study the quantum mechanics, you will come to know that. So according to quantum mechanical explanation, the potential energy for an electron inside the metal is going to be periodic. So this point, it takes care of. Fourth point, the free electron gas in the solid does not obey classical Maxwell-Boltzmann statistical distribution law. Okay, but instead of that, the distribution of particles in an electron gas obeys the Fermi-Dirac quantum statistics. Okay, so the electrons in the metal are distributed in accordance with the Fermi-Dirac distribution function. Fermi-Dirac distribution function prakara electrons distribute ಆಗಿರ್ತದೆ ಅಂತೇಳಿ ಹೇಳ್ತದೆ. But in classical theory, Maxwell-Boltzmann distribution was assumed, but that is not true in quantum statistics. In quantum statistics, the Fermi-Dirac distribution function is used. Okay, so that is how it is having major difference in the distribution law. Okay, classical statistics ಅಲ್ಲಿ Maxwell-Boltzmann distribution law ಅನ್ನು consider ಮಾಡ್ತಾರೆ. In quantum statistics, in Sommerfeld model, we consider the Fermi-Dirac distribution function, which is considered for distribution of electrons. Okay. In statistical mechanics, I think you have studied in the 4th semester, so about the distribution law, etc. You can recall that. 5th point, very important point, in the metal, the energy levels are filled in accordance with the Pauli's exclusion principle, according to which an energy level can accommodate at the most 2 electrons, one with spin up and other with spin down. Okay. So Pauli's exclusion principle has to be taken care. So no 2 electrons can have same set of quantum numbers. So in each state, only 2 electrons can be accommodated. One electron with up spin and another electron with down spin. So the next electron, third electron, should go to the next level. So next level accommodate third electron and fourth. 5th and 6th should be accommodated by the third level, like that. So each level can occupy only 2 electrons. So that is very important concept here. So it takes care of Fermi-Dirac distribution function and it takes care of Pauli's exclusion principle. Okay. Then last point, assuming the free electrons within the metal where potential energy is 0, and using the solution of Schrodinger equation for this case, we get the allowed energy values of electrons within the metal as E equal to n square h square divided by 8 ml square. And here we consider electron as a particle in a box. So electrons in the metal are considered to be particle in 3-dimensional box, where energy of particle in a box is observed to be E equal to n square h square divided by 8 ml square, where n is the quantum number, h is the Planck's constant, m is mass of the particle, and here it is mass of the electron, L is the width of the box. Okay, so energy is quantized. Energy of the electron is quantized. It is in accordance with the particle in a box problem. So these energy values are called as energy eigenvalues, and corresponding energy eigenfunctions are given by psi of x equal to square root of 2 by L into sine of n pi x divided by L. Okay, so this is the 6th point, which says that the electrons in the metal are considered to be particle in a box. Atara consider ಮಾಡ್ತಾರೆ. Okay, so next, Pauli's exclusion principle, Fermi-Dirac distribution function are assumed to be valid in Sommerfeld model. Okay. So these are the major assumptions of Sommerfeld model. So Fermi-Dirac statistics we will consider in the